Imagine you're solving a maths problem and your friend gets a completely different answer. Who's right? The truth is, without a clear rule, both of you could argue you're correct. That's why we use the order of operations. In this video, we'll break down what it is and why it matters, how acronyms like BODMAS can help us remember the steps, and go through some examples to get you feeling confident. The order of operations is the universal sequence we follow when solving calculations. It removes confusion and keeps maths consistent. No matter where you are in the world, this rule ensures that one problem always leads to one correct answer. Without this rule, maths would be chaos. Think of it like the rules of the road. If everyone ignored the traffic lights, we'd crash. The order of operations is the traffic light system for maths. It helps maintain accuracy and consistency, eliminates confusion, and is foundational for learning more complex maths. To help us remember the order, we use acronyms. You might hear BODMAS, BIDMAS, BEDMAS, or PEMDAS, depending on where you are. These acronyms and many more are used all around the world. BODMAS is the acronym I will be using in this video. It stands for brackets, order, division, multiplication, addition, and subtraction. In some places, you'll see BIDMAS. The I stands for indices. You might also see BEDMAS, where the E stands for exponents. And in the United States, you'll often hear PEMDAS. So what's the actual order? Here's how it works. Solve anything inside of the brackets first. Then order, which means powers or exponents. Next, multiplication and division, working from left to right. Finally, addition and subtraction, again from left to right. This is a tricky question, and I promise we'll get to it soon, but let's start off with a simpler one. Here we have 15 minus 4 times 3. According to our BODMAS rule, we always start with the brackets, so the first step will be multiplying the 4 and 3. 4 times 3 equals 12, so we write the 12 underneath and bring the unused numbers and operations down to the next line. Now we have 15 minus 12. This question doesn't include any order or division and multiplication, so we skip straight through to addition and subtraction. 15 minus 12 equals 3, so we write the 3 underneath and we're done. Let's try another one. 12 divided by 10 minus 8 squared. Start with the brackets. 10 minus 8 equals 2. Make sure to bring the leftover parts of the equation down too. Now order. That's our squared number. 2 squared equals 4. Division and multiplication is next. 12 divided by 4 is 3, so our final answer is 3. Now to the tricky one. Told you I'd get to it. As always, we start with the brackets. 10 minus 2 is 8. Order's next. That's 4 squared. 4 squared is 16. Division and multiplication are grouped together, and we solve left to right. In this case, multiplication comes first, then division, but because we're using separate numbers for both, they can be done on the same line. 8 times 3 is 24, and 16 divided by 2 is 8. Now addition and subtraction, working from left to right. 24 plus 8 minus 3 is 29, so 29 is our final answer. As I said earlier, the reason we need to follow order of operations is to ensure anyone solving the same equation reaches the same result. In these two examples, we can see how working from left to right results in a different answer to solving following an acronym like BODMAS. 44 and 23 are two totally different numbers, and this can get very confusing very quickly. Now it's your turn. Practice solving some equations using order of operations. Feel free to pause the video at any point. Answers will be shown at the end of each question. Good luck! So let's put it all together. The order of operations is the rule book for maths. It tells us what to do first, second, and last so that no matter who's solving the problem, we all land on the same answer. Remember the steps. Brackets come first, then order or exponents. Next, multiply and divide, and finally add and subtract. Whether you call it BODMAS, BIDMAS, BEDMAS, or PEMDAS, the idea never changes.